Thank you.
Thank you.
Hi, everyone. Thank you very much for coming. So this is Worms That Turn, Nematodes and Neotodes. Worth pointing out before I start that this content is for educational purposes only. Also worth noting that this can be kind of potentially quite a controversial topic. And this talk doesn't pretend to kind of lean one side or the other. I'm presenting it in a kind of neutral way, just to kind of stimulate some debate and to kind of see what you all think as well. So my name is Matt Wixey. I lead cybersecurity research for PwC in the UK. I'm also a part-time PhD student at UCL, but not looking at worms. And my previous role was in law enforcement in the UK. I worked there for 8 years, leading a technical R&D team. So I've decided to talk about worms and anti-worms because I think it's a really fascinating concept. And there have been some previous talks on it. That being said, it is still quite underexplored in the security world. It goes right back to the earliest days of malware, so right back to the 1970s. I have a general interest in my role in trying to kind of repurpose evil stuff for good. And as far as I know, this concept hasn't previously been considered for IoT. So I'm going to start with talking about what a nematode or an anti-worm is and how it works. I'm then going to cover the history of it from the 1970s, as I said, right up until just last week. I'm going to talk about traditional worms and how they have become less popular with attackers and less feasible. I'm going to talk about some previous attempts to develop anti-worm frameworks and how they kind of fared. I'm then going to talk about something called Neotodes, which is anti-worm for IoT devices, and whether the increase in IoT vulnerabilities and wormable vulnerabilities specifically could make it worth reopening this kind of anti-worm debate. I've got some demos to show you of some anti-worms that I've developed. I'm then going to cover Antidote, which is an experimental framework that we're working on at PwC. And then finally, I'll wrap up and I'll give some ideas for future research as well. So what's a nematode, first of all? So has anyone heard of the term nematode before? Yeah, quite a few people. Okay, so in biology, a nematode can be kind of just a generic term for a kind of worm or parasite, but specifically it's normally meant as a worm that kills other worms or some kind of parasite that kills other parasites. And that's kind of been adopted in security. So it means an anti-worm. So typically it will exploit the same vulnerabilities as malicious worms, but it will then try and do something else. So rather than just kind of add those hosts to a botnet, it may try and patch the vulnerability. It may try and delete traces of the malicious worm, and so on. So there are three different kinds generally: true nematodes, malicious nematodes, and so-called moral nematodes. So a true nematode is benign in intent. It will exploit a vulnerability that is exploited by malicious worms. It will then try and perhaps download a patch and install it, try and disinfect the host, and then try and close any ports that may have been opened, or kind of scrub the host and in some cases reboot it as well. Malicious nematodes are worms that are designed to hunt and seek out other malicious worms, but not necessarily for benign purposes. It's more to kind of add infected hosts to that attacker's own botnet count, for instance. And then finally, the so-called moral nematodes. Now, these don't necessarily exploit any particular vulnerabilities. They are typically worms, but they will do something that the developer perceives to be moral. And I'll kind of come on to a few examples of that and give you some idea of what I mean. So let's have a look at the history of nematodes. Now, bear in mind that I'm going right back to the early 1970s here. I was born in 1987. I know I look a lot older, but I've had a really hard life. So if I have got any of this wrong and you know different, please do let me know. But our first example here is Creeper versus Reaper from 1970. And this is an apocryphal anecdote. The Creeper worm, if you want to call it that, was a program that infected 10x systems. It wasn't wormable in the sense that we understand it now. It, instead of kind of replicating itself, it just transferred itself across the different hosts. And all it did was print out a message to the terminal that said, "I'm the Creeper, catch me if you can." The Reaper worm, which is the kind of apocryphal part of this anecdote, or this particular case, was allegedly a program that did much the same thing. It would try and catch up with the creeper worm, and if it found it, it would delete it. And then there's Animal and Pervade versus Hunter, 1975. Anyone heard of this before? No? Okay, so John Walker developed something called Animal in 1975, which was a kind of guessing game. So it was like a very crude kind of brute force AI program. And it would just say, I'm an animal, you have to guess what I am. And you'd be able to kind of ask it 20 questions and it would try and find out the answer for you. Pervade was a subroutine in that program that enabled Animal to be copied to shared folders. Because the kind of majority of computing equipment at this time was based in academia, you can kind of imagine the faces in some kind of academics when they found that somehow they had a copy of an Animal guessing game in their shared folders. And Hunter, again apocryphal, was allegedly a piece of software that tried to remove copies of Animal from systems that had it on. There's Brain versus Denzuko, so hopefully we're getting more into things that people are more aware of now. So Brain, sometimes called the first true virus, infected the boot sectors of floppy disks and printed out this message that you can see here, obviously talking about a much more innocent time because we've got the malware authors' names and addresses and telephone numbers there. Denzuko was a virus that scrubbed Brain from infected floppy disks. There is an argument as well that Brain itself was a kind of nematode, a moral nematode, in that it was to try and make people aware of the dangers of software piracy. And that's one argument for why the authors' names and addresses and telephone numbers are in there. Co, potassium hydroxide from 1993. So Co has got parallels with kind of modern ransomware. So what Co did was it encrypted your hard disk. But when it was on your system, before it did any of that, it would ask you for the password, the encryption key. So a kind of benign form of ransomware, if you like. And the kind of intention behind it, allegedly, was that was to try and protect your disk contents from people stealing it. So that would be an example of a moral nematode. And similarly, Cruncher from 92, 93 was a disk compression utility. So again, the alleged intention of the author was to kind of save you disk space. There is an argument that it was also developed to be able to get malware to bypass certain antivirus engines at the time. This one's particularly interesting. Anyone familiar with Max Vision or Max Butler? Yeah, one or two. So in 1998, a hacker group called ADM developed a worm for a vulnerability in the DNS bind software that rapidly spread. Max Vision, or Max Butler, as he was at the time, was a white hat penetration tester. He ran a section of whitehats.com, developed a tool called Arachnid, which was a database of attack signatures. And whilst overtly writing an article about the ADM bind worm and how it worked, covertly he developed a nematode for it. So his anti-worm would exploit exactly the same vulnerability in the DNS bind software, but then remove traces of the malicious worm if it was there, download and installed a patch, and unfortunately left a backdoor in those systems as well, which may or may not have been deliberately implanted. He subsequently went to prison, was recruited by the FBI as an informant, and eventually went on to become one of the most notorious and prolific credit card fraudsters of all time. He ran a massive credit card website, which was eventually brought down by the FBI again. So there's a book about him called Kingpin by Kevin Paulson, definitely worth a read if you can get a copy. Polypedo is a great example of a moral nematode. So this is from 2001, very crude malware. It was written in VBS, and it spread via mailing lists. And what Polypedo did, it would search an infected hard drive for images. And specifically, we look for the file names of those images and compare them to a hard-coded list that it had in its code. And it was looking for files that were suggestive of child abuse images. And if it found any, it would email various charities and law enforcement agencies attaching those images. Blaster versus Wiltshire in 2003. So I'm sure you're all familiar with the Blaster worm. which caused a lot of damage and chaos back then. Welchia caused not an insignificant amount of chaos itself. So it was designed to combat the blaster worm, but caused various issues with denial of service as well. Has anyone read Stealing the Network at all? Yeah, one or two. So this is a really good book, if you can find a copy. It's a bit out of date now, so 2003. It's basically kind of short stories written by hackers for hackers. And one of the stories in there is about someone who develops a nematode and the kind of consequences of that. So that's really, really good, worth a read if you can find a copy. The Worm Wars of 2004. So Netsky or Netsky versus Bagel versus MyDoom in 2004. I'm sure you'll all remember this or have heard about it. What was kind of particularly interesting here was you had these different worm authors who were trying to kind of fight for infected hosts, kicking each other off systems, reinfecting systems, culminating in them actually trading insults in their own source code rather than just on forums. And then more recently, ASUS routers from 2014, so a vulnerability in ASUS routers, and some person unknown left out or put text messages on infected routers telling them that they were vulnerable. Mirai versus Hajime 2014 to present, so you'll all be familiar with Mirai. Anyone heard of Hajime? Yeah, quite a few. Okay, so Hajime exploited much the same vulnerabilities as Mirai, and would leave a message on infected hosts, infected IoT hosts again, telling people that they were vulnerable. And this is the message here on the screen. Internet chemotherapy, so Brickerbot versus Mirai Reaper and others, 2016 to present. Anyone familiar with Brickerbot? Yeah, okay, quite a few. So Brickerbot is really, really interesting. Brickerbot was a project run by someone who is still unknown, who in December last year put out this kind of missive on Pastebin and a few other sites, telling people what they'd done and why. And their justification for Brickerbot, so what Brickerbot does, I should say, it's an IoT worm that attempts to brick infected hosts. So it corrupts firmware images, or it tries some other way to make those devices permanently unusable. And the developer's justification for doing that was that by bricking vulnerable IoT devices, it meant that they would no longer be attackable, if you like, by Mirai and Reaper. So it raises some really interesting ethical questions about whether it's preferable for devices to be bricked rather than to be used for, massive DDoS attacks against service providers, that kind of thing. Obviously still illegal in most jurisdictions, but raises some, I think, some interesting ethical questions. Various printers in 2017 were vulnerable to a flaw, and lots of people found this message printing out from their printers if they were vulnerable, basically warning them that the printers had a security issue. And then just last week, there was a report that again, a person unknown had been exploiting a vulnerability in MikroTik routers, but had been patching them. So they had hacked into them, but had then updated the firmware so that they were no longer vulnerable. Okay, so that's kind of a very brief whirlwind history of anti-worms, nematodes, moral nematodes, etc. What we have found kind of in the last few years, things like WannaCry aside, is that kind of traditional network-based worms, so those that exploit network protocols, have decreased in effectiveness, IoT devices aside, when we're talking about kind of Windows hosts, for instance. And various reasons for that. There have been kind of an increase in exploit mitigations in things like, the effectiveness of DEP and ASLR, better antivirus engines. Obviously, they've still got their issues, but much better than they were. Better patching and incident response routines, and generally better security for peripheral devices as well. And I mentioned earlier that nematodes and antiworms have been explored before in previous research. So there have been some other attempts to kind of look at whether this could be an effective security measure, whether it would be worth kind of putting a nematode framework or an antiworm framework out there and using it as a genuine method to try and destroy worms. So probably the first suggested example of this was a guy called Dr. Cyrus Paikari. in 2001 at DEF CON 9. And he came from a medical background, and his position was that if you consider the internet to be a body, like a human body, then you could release some kind of attenuated or weakened computer virus in order to increase its immunity, its immune response. So a very kind of high-level conceptual idea that met with some criticism at the time, but I think it's an interesting argument. The next was Dave Eitel in 2005, who suggested the nematode framework at a Hack in the Box conference. His idea was to have a framework where you could essentially kind of submit the latest vulnerability and it would automatically generate an anti-worm for that vulnerability. HP Active Countermeasures, 2005 to 6. It's hard to find any information about this or much information about this, but it was allegedly a program run by HP which sought to use exploits for good. So to kind of repurpose exploits and use them to protect systems. And then again, difficult to find information about this one, but Fujitsu in 2012 were allegedly working on something similar. And the people who've kind of suggested this previously have been of the opinion that there are multiple benefits to having anti-worm frameworks and using nematodes. The first is obviously that you can kind of rapidly assess a network as to whether it's been affected and how vulnerable it is. And if it has been affected, you can disinfect it rapidly. There are kind of side benefits to it, so large-scale system management, distributed searching, because essentially every host becomes a scanner, right? The more systems that become affected, they then scan for other vulnerable hosts. So you could do things like self-discovering networks, for example, and discover things like shadow IT. The counter-arguments to all of these, and as I mentioned earlier, this has been kind of quite a controversial topic. The first is legality. So it doesn't matter what you're doing. If you're kind of affecting someone else's computer system that's not yours, you're breaking the law in most countries. So really, this would only kind of be suitable for private networks, for networks that you own. There's an ethical issue with it as well. So a lot of people, quite understandably and quite reasonably, don't like the idea of someone else patching their own equipment. If you look at the kind of MikroTik example from just last week, the person who was doing that was posting in a Slack channel with each host that they patched and the IP address. And a few people said, thanks for patching my router, but the majority of people were outraged, kind of understandably. There's a trust model issue as well. So how do you know that someone who develops an anti-worm is any more trustworthy than someone who develops a worm? There's an issue potentially with denial of service and with bandwidth. So the fact that every host becomes a scanner, previously with other anti-worms in the past, they've caused denial of service issues because it creates a lot of traffic, obviously. They can be hard to target and control. So whilst you may only start looking at a private network and deploying a nematode onto that, obviously if that nematode then gets out somewhere, that is potentially going to cause some issues. And there's also the fact that worms are difficult to do well. They're not an easy kind of malware to develop. Or they're difficult to develop in an efficient and effective way, let me put it that way. So to kind of sum up this kind of era then, so kind of pre-2012, there were these kind of several frameworks that were proposed. None of them actually kind of went anywhere as far as I'm aware. Excuse me. Predominantly because those proposals didn't beat that kind of fear factor, the kind of people saying, I don't want a worm running on my network, I don't care what it does, I just don't want it. Combined with that demise of those traditional network protocol worms, it kind of meant that maybe there was less of an argument for actually using nematodes anyway, because it became a much less common occurrence to have a worm on a network. So that concept pretty much kind of died a death. Except with the kind of rise of connected IT, of IoT devices, smart devices, there's been a massive plethora recently of wormable vulnerabilities that have been found in IoT devices. And as you know from Mirai and Reaper and various other kind of IoT botnets, it's a problem that doesn't seem to be going away. So here are some examples, and it's not just limited to IoT, it also includes other devices as well. So starting from the top left, the Philips Hue light bulb. A couple of years ago, some researchers at Black Hat found that it was possible to create a light bulb worm. So this light bulb used Wi-Fi to connect, and they did create a worm that could be spread through light bulbs, through smart light bulbs over Wi-Fi. What that meant was that they could make a smart city, for instance, a whole street go dark within seconds. There's been Broadpone, which was vulnerability in Wi-Fi chipsets, also wormable. RFID chips and tags. So this one's a little bit older, but very interesting. Again, this was at Black Hat. This was based on the concept of first RFID readers being infected with malware. I think the example used was an SQL injection vulnerability, with the ability to then have or to transfer an exploit payload onto every RFID tag that touched that reader. And obviously those RFID tags, when they're next put against another reader, would then try and exploit that reader. The Arduino Yun, popular Arduino board, was found to be vulnerable to a couple of buffer overflow vulnerabilities recently, which again was wormable. And then you have various IoT devices as well. So that being said, is it worth kind of reopening this debate? So what's the kind of issue with connected devices, IoT devices, smart devices, RFID devices, is that traditional vulnerability management doesn't always apply, right? So you can't necessarily have exploit mitigation mechanisms and antivirus engines on IoT devices. You might be able to a limited extent, but certainly nowhere near the amount that you could do with kind of traditional workstations. Applying patches can be difficult. So firstly, you have to wait for the manufacturer to issue a patch. Typically, you're going to have to do a firmware update to apply that patch. In some devices, like RFID devices, for instance, it might not even be possible to apply a patch at all. Similar with kind of hardware vulnerabilities, you just have to wait for the kind of latest iteration to come out. It can be quite time consuming to apply those patches as well. There's also the issue of shadow IoT, so people kind of bringing in smart devices to work, connecting them to the work Wi-Fi, for instance. And also generally, I think kind of anti-worms and nematodes are really interesting as a demonstration tool to kind of illustrate to people, this is the effect that a worm can have, this is how rapidly it can spread. Okay, so I'm going to run through some demos. So the first one is a demo of a true nematode. So this is one that I've created. It's a recent exploit, and as far as I know, it hasn't been made wormable in the wild. It's a command injection vulnerability in a web application called ClipBucket, which is a kind of photo sharing application. So I wrote a worm in Python for it, a malicious worm. What the malicious worm does is it exploits the command injection vulnerability. It will then download and execute a copy of itself, scan for other vulnerable hosts on the network, and we'll also put a web shell on the infected machine and then scan for new targets. So the nematode is obviously based on the malicious worm. It exploits exactly the same vulnerability. It will search on the infected system for the evil worm and the backdoor and delete both of them. It will remove the vulnerable functionality. So this is potentially a controversial bit. I'll just put it in this demo. So the vulnerable function is in a PHP page in this web application, a PHP script. So the nematode it removes that vulnerable PHP script, renames it, and puts a warning to the administrator or the owner. The nematode will then scan for new targets, and it will then replicate. So this is quite a long demo, so I'll skip through some of it. So we've got the setup here is we've got 4 vulnerable virtual machines running ClipBucket and 1 attacker machine. So this is the ClipBucket folder at the moment. If I just go back. And the vulnerable PHP script in question is file_uploader.php. As you can see, nothing else in that folder at the moment. It's all as it should be. And just checking that's the same for all hosts. Okay, so this is now launching the worm. So it's scanning through a particular subnet. When it finds a vulnerable host, it will exploit it, and it will report back to a dashboard through a very primitive C2 channel. There we go. And then when we look at a host that's been infected, you can now see that there's a shell.php script that's been put onto that folder, and a copy of the worm itself in Python. And it's copied itself over to the temp folder as well. So that shell.php is just a very primitive one-liner web shell. And that's the same for all 4 hosts. So the web shell just gives you very simple command execution vulnerability. Obviously, a genuine attacker would put something a bit more sophisticated on there, potentially, but just to demonstrate that it works. There you go. Okay, now this is the nematode. So the nematode will do pretty much the same thing. It will scan through, it will find vulnerable hosts. If it finds them, it will report back to a dashboard. Okay, so there we go. And if we now look at the folder for ClipBucket, you can see that the shell.php has disappeared, but the nematode Python script is now there. You can see it's renamed the vulnerable PHP script to .bak, and it's put a new one on there. And if we have a look at that, that's the kind of message that will get shown to the administrator or the owner. So this is an example of a kind of traditional true nematode. It's pretty primitive. It's written in Python. I don't claim to be a decent developer, let alone a kind of decent worm developer. But this is an example of that. So the kind of scenario where that might be useful is if you discover that a new vulnerability has been published, you kind of subscribe to vulnerability feeds, and it's potentially wormable, or you start to hear that a worm exists in the wild for a particular vulnerability. You could launch a preemptive nematode that checks for that worm on your network, or checks for that vulnerability on your network, and if it's found, it removes and patches it. Okay, so demo 2 is an example of a neotode, of an IoT vulnerability for which I've written a worm and an anti-worm. So this is a kind of generic IP camera. It's got 2 vulnerabilities which can be chained together. So pre-authentication credential disclosure to log into the camera, and then authenticated command injection. So these vulnerabilities have been, and others have been reported to this particular vendor before, and they have tried to address them. So initially you could telnet into these cameras as root without authentication. The telnet daemon is no longer enabled by default. Users are now explicitly encouraged to change the default password for the camera. There is still a default password, but at least now they're kind of asked to change it. And if the camera gets an IP address via DHCP, then the HTTP port that's used for the kind of web interface is randomized. But those underlying vulnerabilities are still present. So the worm that I wrote, it retrieves credentials from the web servers it finds. It uses those to then execute authenticated command injection. And obviously, as a single attacker, you could use that to re-enable telnet, which will still give you a root prompt. So feeling a bit masochistic, a bit brave, this worm was written in Bash. Turns out Bash isn't installed on this camera, so I had to change it to a POSIX shell worm instead. There's also a character limit on commands. I think it was like 34 characters, which made this quite a challenge as well. So what the worm does is it retrieves a .ini file from the camera's web server that contains the credentials in plain text of the user. It extracts those, it injects some commands. It will then copy and retrieve a copy of itself from the camera's web server and then scan for other hosts. So I put these cameras on sequential IP addresses with a static HTTP port just so the demo doesn't take ages, but in real life, obviously, an attacker would scan through everything. And then to demonstrate that the cameras have been infected, once they have been infected, the cameras will start spinning round and round. The nematode will then infect those spinning cameras and it will stop them spinning. Oh yeah, and also on the kind of malicious infection, telnet will be enabled, so the attacker will be able to telnet in. The nematode will then disable the telnet daemon again. Okay. So these are the 3 cameras. There are 3 of these here. These are all on the same Wi-Fi network. So you can see initially I can't telnet into these devices, which is kind of what you'd expect, what you'd hope for. If I then run the malicious worm, this will start scanning through for vulnerable hosts, and you can see it then makes them start to spin. So as the infection catches, they all spin. Okay, I'll skip forward a bit. So now you can see I can telnet in with root privileges just there to these devices. So the telnet daemon has been re-enabled. I'm now going to run the nematode. So exactly the same thing, finds the credentials, does the authenticated command injection, and you'll see that it stops them spinning. And then I'll skip forward a bit because this takes a while, but it has also disabled telnet again. So I'm now no longer able to telnet into these devices. Okay, and my last demo is a novel so-called moral nematode. So this is based on, or an improvement of, the Polypedo device. Now I want to say, kind of first off the bat, I'm definitely not advocating that anyone do this, launch anything like this against anyone. I just thought it would be interesting to see if I can improve on the concept. So Polypedo wasn't that efficient. It spread via email. It was a VBS script, and it determined so-called illegal content by file name. So it wasn't even looking at cryptographic hash. Now, obviously, if you're trying to compare images to something, MD5 is the most common way you do that, or some other kind of cryptographic hash. That does have some flaws. There's the very unlikely potential for a hash collision, but mostly the fact that if you just make a slight edit to an image or resize it or change the color ratio or something like that, you get a completely different cryptographic hash. So the solution is something called perceptual hashing, which is very interesting, not a new concept, but something that I want to have a look at. So a perceptual hash is a measure of similarity. There are various ways you can do it. I've done a particularly crude algorithm in this example, but there are kind of more sophisticated ways you can do it. And it's basically based on the value of each pixel once an image is reduced to grayscale. And it's based on the kind of distribution of pixel values across an image. And you could then compare that string to others generated for other images you're looking at. So essentially, it's just a string comparison by the end of it. So for a pretty simple algorithm, it's pretty resistant to things like resizing, to small edits, to sequential video stills from the same video. So what my novel nematode, moral nematode, does is it will scan a folder for image files. It will generate perceptual hashes for each of those images, and it has a hard-coded list of bad perceptual hashes. And if the match is over 90%, it will send an email and attach those images. The infection is via USB, so it will check I think every 5 seconds for attached removable media. And if it's found, it replicates itself onto that device as a hidden file, creates a visible shortcut with a notepad icon, and the target of that shortcut is the executable. So specifically what my demo is looking for is resized images. So in this case, an image of a plane, an image with a slight edit. So you can see there's just an edit been made on this image here, and visually similar images. So these are stills from the same video, but at different points. So you can see by inspecting them, they're obviously not the same image, but very similar. So at the moment, the email inbox is empty, as is the USB drive that's attached to this computer. These are the original signatures of the image, the kind of things that are hard-coded into the demo. And these are the images that we want to compare against. So the example image, the plane, and one video still. And then on the user's computer, these are the images that they have in their folder that we're going to compare against. So you can see there we've got similarities of 95%, 98%, and 93% for those images. So it's then going to send an email for each of those and replicate itself across to the USB drive. So these are the emails that have been sent. So it tells us the similarity score, attaches the images as well, and does that for all 3 of those images. And then it's also, as I mentioned, replicated itself across to the USB drive. So the way that looks in practice is you have a shortcut there with a notepad icon, and the target for that is the hidden exe file. So the idea is that when this user would then take out the USB stick and plug it in somewhere else, it would then, once they click on that file, it would then do the same thing for whatever computer they've plugged that USB drive into. Again, this is presented for educational purposes, definitely not advocating people go out and do this. It's just an interesting thought experiment, if you like. And you could make kind of future refinements to this. You could have like a depth count. You could try alternative replication methods, that kind of thing. Lastly, I want to talk about Antidote very briefly. So Antidote is a framework that we're working on at PwC. The goal is to maybe have a kind of modular, free, open source framework for IoT anti-worms, where similar to Metasploit, modules will be QA'd centrally, and you'd be able to deploy and use the payloads that you want on your own networks. So you'd be able to customize payloads, replication, delay between scanning hosts, whether it's a reboot, whether it's a patch, that kind of thing. And specifically at IoT. I have a demo, but I'm running a little bit out of time. So if you want to get involved, just let me know. If you want to see the video, let me know. We're definitely still at the very early stages of just kind of sounding out, A, whether people think this is a good idea, and B, whether it's feasible or possible, whether anyone would actually use it. If you've got any thoughts, ideas, comments, that's my Twitter handle. It's still in the planning stages, but could be kind of quite an interesting community project, I think, and a kind of collaborative effort. So to wrap up, nematodes originally were a novel idea, but just not successful for a variety of reasons, and over time became kind of less necessary anyway, or less kind of relevant. But neotodes, potentially, IoT worms, present a significant threat, and carefully designed anti-worms may be able to reduce that threat. There are potentially other benefits as well. There are concerns you still need to be mindful of, but potentially this could do that. This could kind of be a possible solution to that problem. As attackers develop new approaches, then potentially we need new defenses as well. Antidote is kind of one approach to that problem, or to solving that problem. And if nothing else, hopefully it will stimulate some debate and get some conversations going, as well as potentially being a crowd-based solution. So lots of references here on the slide deck. If you're interested, if you want to kind of do your own digging on nematodes and anti-worms. Thoughts, questions, feedback, my Twitter handle or my email address, and I will wrap it up there. Thank you very much.